Let us look at problems on steady state errors. The first problem statement is like this. A unity feedback control system has open loop transfer function g of s is equal to 10 by s into 1 plus 0.1 s into 1 plus 0.5 s. Find the steady state error for the input r of t is equal to 1 plus 2t plus 4t square. Now, so we need to find the steady state error. We know to find the steady state error, we need to find steady state error constants kp, kv, ka. Now the input is not single input, so we have a combination of inputs. Let us look at inputs. So r of t is equal to 1 plus 2t plus 4t square. Now when you apply the Laplace transform to this, then you will be getting r of s as the 1 is 1 by s and your 2t is going to be 2 by s square. Then 4t square is going to be 8 by s cube. By looking at these three terms, I can say the first one 1 by s is the step input, then 2 by s square is a ramp input, and 8 by s cube is the parabolic input, where the magnitude of the input r1 is 1 and r2 is 2, r3 is 8. Now, since the system is a linear system, then I can find the errors for three different inputs, then finally I can add the error to get the total steady state error. Means your ESS is equal to ESS1 plus ESS2 plus ESS3. What is ESS1? Is a step. So let us find out what is the Kp for that. You know the Kp formula, limit s tends to 0, g of s. So g of s is available when you substitute here, and substitute s tends to 0, the Kp is going to be infinity. When Kp is infinity, what is the corresponding steady state error? ESS1, we know that it is r divided by 1 plus Kp, it is going to be 0. So ESS1 0, which means when you apply 1 by s step input to the given system, the error is 0. Take the second case, where the ramp input, what is the ramp magnitude? It is 2. So whenever the ramp input is given, what is the corresponding error constant? Kv. So what is Kv formula? Kv is limit s tends to 0, s into gh of s. So we know what is gh of s. Of course, g of s is given, h of s is 1 for unity feedback system. Then we can cancel ss here, we will be getting Kv is equal to 10. Then Kv is 10. What is the corresponding error? ESS2, it is r by Kv. That means 2 by 10. It is going to be 0.2. So we have a definite amount of error appears here whenever the ramp input is given to the system. Then the third case, a parabolic input, where r3 is 8. Therefore, when parabolic input is given, then corresponding error constant is Ka. So Ka formula we know, limit s tends to 0, s square into gh of s. When you substitute, you are getting Ka 0 and corresponding error is infinity. Then what is the total error? ESS is ESS1 plus ESS2 plus ESS3. 0 plus 0.2 plus infinity, and the final error is going to be infinity. So by looking at the system itself, we can say that because system is a type 1 system, and input out of all these input there is a parabolic input. We can call back to the table which is available in steady state errors. Whenever the parabolic input is given to a type 1 system, we know that error is going to be infinity. So that error is infinity. When you add infinity to any other errors, that is going to be infinity only. Directly answer we can say it is infinity, but using the method also we can find out, you can prove that it is going to be infinity. The open loop transfer function of unity feedback system is given by g of s is equal to k into s plus 1 by s square into s plus 2. Find the value of k such that the system will give you maximum steady state error of 10 when the input r of t is equal to 2 plus 10t plus 20t square. Now in this particular system, I need to find what is the k value for the maximum steady state error 10. The procedure is same. You know the input, there are three inputs available. For each input, I will find out the steady state error and I equate it to 10, then I can find out what is the k value. Now, so input r of t is given it as 2 plus 10t plus 20t square. Then when you take the Laplace transform of that, r of s is going to be 2 by s plus 10 by s square plus you have 40 by s cube. Now, so this is step, ramp and parabolic. So whenever you have a step, we can find out ESS1. Then what is the Kp? Kp is limit s tends to 0, g of s. When you look at the open loop transfer function, it is a type 2 system. When you have type 2 system, your Kp is going to be infinity, Kv is going to infinity, and corresponding errors are going to be 0. We can also solve by using the formulas. So when you substitute here the Kp, limit s tends to 0, gh of s, and your Kp is going to be infinity, which means the corresponding error is 0. Similarly, when you take Kv, so Kv is limit s tends to 0, s into gh of s, then when you substitute there your gh of s here, again you are going to get the infinity. Then what is the corresponding error? R2 by Kv, so that is also 0. Then the third, your parabolic input. So when parabolic input is given, what is the corresponding steady state error constant? Ka. Ka is limit s tends to 0, then gh of s, s square into gh of s. You can cancel s square, then the remaining will be you have k into 1 divided by 2. So k by 2 you will be getting. Then what is the corresponding error? So error is nothing but R3 by Kv. So then finally you can add ESS1 plus ESS2 plus ESS3, then 0 plus 0 plus you have 80 by K, because R3 value is 80 by K, and that I am equating to your maximum value of error, that is error is going to be 10. So what is the corresponding K? K is 8. That means when you fix the K value 8, then I can go to the maximum steady state error of 10. So next look at the another problem. The block diagram is given in this particular system, and find the steady state error for the system, and the input is step input. Unit step input is given. What will be the steady state error? The block diagram is available to me. We know that to find the steady state error, we must know two informations. One is what is the open loop transfer function, and what is the type of input connected, means step, ramp, parabolic, and so on. Whereas in this particular block diagram, we cannot get the open loop transfer function. Okay, then what I can do is find out what is the closed loop transfer function, convert that closed loop transfer function into open loop transfer function with the assumption h of s is equal to 1, and for that I can have Kp, and from that Kp I can find what is the steady state error. So now, this block diagram I am converting into a signal flow graph like this. Once you have the signal flow graph, then I can apply my Mason's-Gain formula, then I can find out the closed loop transfer function. Then when you look at the signal flow graph, it is very clear there are two forward paths and there is only one feedback path. So the transfer function we can write it as T of s is equal to, you have numerator s plus 9 divided by you have 3s plus 1. So this is the transfer function which you are getting, and from that I want to get what is the open loop transfer function. The open loop transfer function g of s is nothing but t by your 1 minus t. If you have closed loop transfer function, it is g by 1 plus g. When you have a reverse, if you do the reverse, it is t by 1 minus t. Then if you find out that your g of s is going to be, you can write like this, because you know that already t is a transfer function, t is s plus 2 by 3s plus 1 divided by 1 minus s plus 2 by 3s plus 1, and equal when you do the simplification, you will be getting the g of s as s plus 2 by 2s minus 1. This is my g of s. What is the type of this? It's a type 0 system. So for type 0 system, there exists a Kp. We can find out the Kp. Kp formula is limit s tends to 0, gh of s, that is going to be minus 2. When you substitute ESS, that is r by 1 plus Kp, that is 1 by 1 plus Kp is minus 2, ESS is going to be minus 1. So the steady state error for the given block diagram system is minus 1. So minus 1 is also non-zero, because error can be anything. Error can be positive, error can be negative. So depending upon that, the controller will take the action. Now, so when you closely observe the open loop transfer function and closed loop transfer function, the closed loop transfer function is s plus 2 by your 3s plus 1. When you look at poles and zeros, there is a 1 0 and 1 pole, both are lying in left of the S plane. It is a stable system. Whereas when you look at the open loop transfer function which we got, it is s plus 2 by 2s minus 1. That means there is a 1 0 at the left of the S plane, 1 pole in the right of the S plane. So even though your open loop transfer function is unstable, but my closed loop transfer function is giving a stable result, and we will have a specific steady state error. And steady state error concept is possible only if the closed loop system is stable. If the closed loop system is unstable, so the output varies continuously, we cannot find the steady state error.